Today's lesson is FIF.8, Day 1, Perfect Square Trinomials. Take a look at this warm-up, and I want you to factor each of these trinomials into the product of two binomials. Now, you learned this skill in Algebra 1. You used it a lot that year. Maybe even had to use it some during your geometry year. If you need a refresher, let's take a look at this example. Here is x squared plus 7x plus 10. When you want to factor this trinomial into the product of two binomials, you should be thinking of what are some factors of 10, think of them in pairs, whose sum is 7. So when I would teach this in Algebra 1, I'd put a multiplication dot above the 10 to trigger your thinking of what times what, and pick the pair of numbers that when you add them, give you 7. 2 times 5 is 7. 2 times 5 is 10. 2 plus 5 is 7. So when you factor it, it factors into the product of x plus 2 times x plus 5. So pause the video here for a minute and factor each of these 4 quadratic equations. You should be seeing a pattern that it ends up, unlike this little review example, each binomial is different. As you factor each of these, each of your binomials will be the same. So when you factor the first one, 2 times 2 is 4, and 2 plus 2 is 4. But a mathematician would say, I'm not wasting my time writing the binomial twice. I'm going to write it once and indicate repeat multiplication. We are squaring that binomial. With number 2, 3 times 3 is 9, and 3 plus 3 is 6. But don't write it twice. Number 3, 4 times 4 is 16, 4 plus 4 is 8, and so forth. So these trinomials that I asked you to factor were handpicked. They were special because every time you were factoring them, they ended up being the square of a binomial. I gave you perfect square trinomials. So let's focus now on these numbers that are represented as the coefficient of x. We refer to that as b when we think of a quadratic as being an ax squared plus bx plus c. Look at the numbers in the b position and look at the numbers in the c position. So as you think of an x squared plus bx plus c, pretty basic quadratic equation, I want you to think about what could you do to the number in the b position to get the number in the c position. Well, 4 times 1 is 4, but 6 times 1 isn't 9. So that pattern that we saw with the two 4s doesn't hold up for the others. And actually, when they're both 4s, it's kind of hard to see a pattern. Even with this example, you could say, oh, 8 times 2 is 16. I've got the pattern, but 6 times 2 is not 9. Take a closer look, pause the video if you need to, and think about what you could do to 6 to get 9. What could you do to 10 to get 25, as long as that pattern holds for every one of these problems? Hopefully you're recognizing that if you take the number in the b position, divide it by 2, and then square it, you get the c number. 4 divided by 2 is 2. 2 squared is 4. 6 divided by 2 is 3. 3 squared is 9. 8 divided by 2 is 4. 4 squared is 16, and so forth. So what you've recognized is the pattern that's set up when you have a perfect square trinomial. So this is the basics of what a perfect square trinomial looks like. What we're going to have to do is to forcibly create perfect square trinomials. We also should recognize that if you don't have one, you can create one. And that's what we're going to learn how to do this lesson. In the Day 2 lesson, we'll use that for another purpose. So in this example, I put a big square here that we need to figure out what number would force a perfect square trinomial. Well, from the pattern, we should be taking 16 divided by 2, getting 8, and then squaring it. Oh, 64 is the number I need to make a perfect square trinomial. And then, to further the pattern, we also saw that this trinomial would factor into an x plus b divided by 2. the quantity squared. So this will factor into an x plus, well, 16 divided by 2, that was 8, the quantity squared. So with this lesson, we're going to practice how to create perfect square trinomials and then to factor them using the pattern that's been established. The pattern that hopefully you recognized. Here's another example. What should C be to make a perfect square trinomial? You should be taking negative 26 divided by 2. That gives you negative 13. Carefully square that number. Carefully, if you need to do it on your calculator, better put parentheses around that negative number. It could, because if you take a negative times itself, you'll get a positive. So positive 169 is what C should be. And then if you're next asked to factor it, you should easily be able to say it's going to be x plus, what was B divided by 2? Negative 13, the quantity squared. Let's try 2 more before it's homework time. Let's try a few where you might get a fraction. 11, that's our B number. What should C be? Now pause this for a moment while you think carefully about how you come up with C. B is 11. Well, 11 divided by 2, then we have to square it. So hopefully you remember, if you're squaring a fraction, you should square the numerator and the denominator. So if you're going to take B divided by 2, you'll have 11 over 2. Square 11, you get 121. Square the denominator, that was 2. Square 2, you get 4. So the number you need in the C position is 121 over 4. How was that created? That was 11 over 2, the quantity squared. And then you can factor it into x plus B divided by 2. All of that entire sum squared. Let's try one more with a fraction. Can you figure out what C is to force a perfect square trinomial? 1/3 divided by 2. 1/3 divided by 2 is 1/6. Then when you square 1/6, you'll square the 1 in the numerator and square the 6 in the denominator. So the C you're looking for is 1 over 36. Factor into an x plus. What was 1/3 divided by 2? 1/6. So x plus 1/6, the quantity squared.